Okay, in this video we're going to look at some past paper examples of similar shapes, but before we get into that I just want to explain something really quickly just regarding similar shapes. So let's say there's a line that's 5 meters and I have another line that's 10 meters. Now this could be part of a shape or something. If I go from 5 to 10, I obviously know I have to multiply by 2. So my scale factor in this case is 2. Nothing weird there or anything. But if I went and I drew, let's say I kind of did this. Well, let's just stick with the blue. If I drew a square here and make it 5 by 5, and similarly I have another square here that's 10 by 10. If I work out the area of this, suddenly 5 times 5 is going to be 25 meters squared. And 10 times 10 is going to be 100 meters squared or square meters. So I saw here my scale factor was times 2 when I looked at the 5 and the 10. But with the area, I see something's happening because 25 times 2 is not going to give me 100. So what's actually happening here is because I'm working with area, my units are squared. So my scale factor needs to be squared as well. And then I can see, okay, well, 25 times 2 to the power of 2 or times 4 is going to give me 100. And in the same way, if I made a cube and all the sides were 5 and I had another cube and all the sides were 10, let's make it 10, then 5 times 5 times 5 would be 125 meters cubed. And this would be 10 times 10 times 10, which is 1,000 meters or cubic meters. And in this case, well, I'm used to my scale factor being 2, but now my units are cubed. So now my scale factor needs to be cubed as well. And I can see 2 to the power of 3, 2 times 2 times 2 is going to be 8. And 125 times 8 is going to give me 1,000. So I just should always be aware of what units I'm working. If I'm just using straight, just normal meters or centimeters or millimeters, then my scale factor just stays the same. Very, very similar to what we've always been doing. But as soon as I go to something like area, I have to be aware that my scale factor is also increasing by, to the power of 2. And if I'm going to cubic meters or any volume type of equation, then suddenly I have to take my scale factor and cube it. Okay, let's take a look at some of these past paper examples. Just take this off. So our first example is, here we go. They say a shape P is enlarged by a scale factor of 3 to give shape Q. So I'm going to write P. We're going to multiply it by 3. And this gives us Q. And then Q is also enlarged by a scale factor of 2 over 5. So then Q is then multiplied by 2 over 5. This would actually make it a bit smaller. And then we would get R. And they say the area of shape P is 10 square centimeters. So because this is square, they're asking calculate the shape R. Now, obviously, it won't just be 10 times 3 times 2 over 5. That would be too easy, right? So we have to remember that we're working with, square units. So basically, I'm going to take the 10, I'm going to multiply it by 3, but not 3 alone, 3 squared. And I'm going to multiply that number by 2 over 5 squared. And that would give me my R. So let's just take a look at that. So it's going to be 10 times 9 times 4 over 25. And if I work that out in my calculator, just 10 times 9 times 4 all divided by 25, it's going to give me 14.4. My units were square centimeters. Cool. Just a very nice little example there of how how to work with area. So for our next example, have a nice big page here. Just put that up there. Very nice. And for this example, they say, look, we have two shapes that are mathematically similar. So obviously that gives it away that they are in a scale. So they say find the value of h. So h is kind of the height there, I guess. So I just have to figure out how much it's increasing or decreasing if I'm going from 9 to 5 or 5 to 9. So the simplest way would just be to say 9 divided by 5. So 9 divided by 5, it's 1.8. So I know the scale factor is 1.8. If I'm going from here to here, I have to multiply by 1.8. Or if I go from there to there, I have to divide by 1.8. I could do it a different way as well. I could just write the ratio of, 6.3 over 9 would be the same as h over 5. And then I could cross multiply and say 6.3 times 5 is the same as 9h, and divide both sides by 9. Or I could just say 6.3 divided by 1.8. Hopefully I get to the same answer. So let's say 6.3 divided by 1.8. That gives me 3.5. And that is centimeters. Again, nothing weird there. It's just straight centimeters. And let's say if I did this, if I said 6.3 times 5 and I divide that by 9, how lucky am I get to the same answer. So either way would work. But yeah, so that's the simple part. And the scale factor of 1.8 is kind of important, so I'm just going to write that. This is my scale factor. It's important before I rub all the rest of this stuff off. There we go. And the second part of the question is, they say the area of the smaller shape is 16. So let's say I'm going to redraw this. This is the big shape and this is the small shape. And they say this is 16, say cubic, well, not cubic, square centimeters. They want the larger shape's area. So I know the scale factor, as I wrote there, is 1.8. So because it's written like this, I'm going to go the other way. I would want to multiply this by 1.8, but because this is square units, I'm going to have to multiply by that squared. So let me just do that. 1.8 squared is like 3.24 times 16, and that gives me 51.84 units here, or square centimeters. So just like I said, we worked out the scale factor for the first one just to be 1.8, and because we're working with area, we take that scale factor and we square it. If it was volume, if they said, hey, the one is 16 cubic centimeters, then we would have just said, well, 16 times 1.8 cubed to get obviously a different answer there. Okay, so these are still kind of pretty straightforward. Let's take a look at, I have, I think, 2 more here. This one's quite nice. So a sector of a circle, I usually like to draw some pictures, make my life easier. The sector of a circle, so let's say there's a sector of a circle. It has a radius of 8 centimeters. And the area for this is, let's say, 160 square centimeters. And a mathematically similar sector, so there's a similar one that's obviously bigger because it has a radius of 20 centimeters. Mathematically similar sector has a radius of 20 centimeters, and calculate the area of the larger sector. So I want to know the area. So if I can find out what the scale factor is, what did I do with 8 to get to 20, then I can probably, well, we'll take it from there, but then I'll have to take that square factor and I have to, scale factor, and I'll have to square it to get to that area. So to find out what I did, I'm just going to do 20 over 8. So 20 divided by 8, 20 divided by 8, that gives me 2.5. So I know I had to multiply by 2.5. So 8 multiplied by 2.5 gives me the 20. So in order to find the new area, I'm going to take 160 times 2.5. But because I'm going from, I'm working with area, it's going to be squared. And I have to work out 2.5 squared. That's 6.25, and then times 160, and I just get 1,000, what are we working with, squared centimeters. Okay, very simple. Now for the big guns, the tricky one. Okay, next one is, I'm not really sure how many marks this is, but I know it's definitely a big question. So I'm going to start with pictures again. They say there's a bronze statue. So let's just make this as let's say it's a person. A bronze statue, and it has a height of 4.5 meters. And it has a mass of, let's write the mass here, in 195,200 kilograms. And it's obviously made from bronze, and the density of bronze is 8,000 kilograms. Sorry, kilograms per cubic meter. And then they say there's a mathematically similar model. So because it's a model, I assume it's going to be smaller. So let's just do a little model there. And they say the volume of a mathematically similar model is, they gave me the volume here. I'm going to write the volume. Let's make it in black. 0.385 cubic meters. And they say calculate the height of the model. So we need to find the height. Okay, so they gave us this volume. And they gave us a little equation there saying density is mass divided by volume. For the big one, they did give me mass and they did give me the density. So I assume I can actually work out the volume, and then I have kind of similar stuff here, volumes being, I can compare volumes. So in order to work out the volume, I'm going to go with density is mass divided by volume, like they told me. The density here, they said the density of bronze is 8,000. The mass they gave me is 195,200. And then the volume is what I'm going to try and work out. So I can work out volume is going to be 195,200 divided by 8,000. And that is, if I do it on my calculator, 195,200 divided by 8,000, 24.4. So now I have 24.4 cubic meters. Okay. So this is kind of a backwards one. In the other examples, I would have this height and that height, and I would work out what the scale factor is. And then I would either, if I'm working with area, I would square, and this is volume, so I would probably cube it to get to the new volume. But now it's kind of backwards. So basically, if I had to write this, not very algebraically, but just kind of as a word problem, I'll say there's this small, let's say height, times a scale factor. And that scale factor, oh no, okay, we'll take the small, okay, no, I mean the small volume. I'm going to take the small volume times the scale factor, but because it's volume, it has to be the scale factor to cubed. And that would give me the large volume. Okay, so if you remember, like in the beginning of the video, we had that if I had a little cube and I said the cube is, let's say 5, and there was another cube with side lengths of 10, then this would be the small volume, which is 125. My scale factor here I would have worked out using the h and the 4.5, but I don't have that now, but in that case it was 2. And then I had to, like the scale factor here, and then I had to cube it to get to this 1000. Okay, so in this case my small volume is 0.385. My scale factor is unknown, so I'm going to call it x. I don't know what it is. And I know I'm going to have to cube it, and that would give me the answer of 24.4. So now I kind of just have to rearrange this formula. Let me just move this a little bit up. So basically, if I divide both sides by 0.8, sorry, not 8, 0.385, 0.385, then I'd be left with x cubed is whatever that is. But I don't want x cubed, I want x. So basically x would be the cube root of that thing, 24.4 over 0.385, and eventually I would work out that x is on my calculator. That works out to 3, okay, just write a little bit better here, 3.986970592 blah 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 blah. So now I know this is my scale factor, but I'm not done yet. So basically the scale factor here is, it's very close to 4. So because I'm going smaller, I'm going to have to divide by my scale factor, which is 3.98. So if I take 4.5 divided, 4.5 divided by a very long number here, where can I write it? Do I have any space? Not really. Let's do it in the corner here. Do I have space? Yeah. So 4.5 divided by my scale factor, which I worked here, is 3.986970592. Obviously, you'll just keep that on your calculator. And if I divide that, I get 1.128 and lots of numbers. And I just want to have, just convert it to, I see I'm out of space there. Convert 3 significant figures, so it would be 1.13, and that's in meters. So this was a bit kind of the other way around. Usually they'll give us this height and that height, and then we'll divide them to get the scale factor, and then they'll give us maybe this volume, and then I would have to take the scale factor and cube it, and then multiply this times the scale factor cubed to get to there. But now it was the other way around. They gave us the 2 volumes, and then we had to kind of get the cube root. So if it was a problem where they gave us areas, then we wouldn't get the cube root here. It would be the square root, because obviously the scale factor would have been squared and not cubed in that case. Anyway, I hope you found that helpful. Yeah.